Right, okay, so here we go with the test on coordinate geometry and circles. Let's see what we've got to do on this one. Okay, so first one, they're giving us the formula, which is very nice of them. We've got gradient 3, and we've got a point for x and a point for y. So all we need to do is substitute straight into this. So as long as I've got my pen selected, I'll be fine. Y minus y1 is equal to mx minus x1. And so we're just going to have y minus 1 is going to be equal to 3 is the gradient, x minus 4 for x, and so that's y plus 1 is equal to 3x minus 12, or y is equal to 3x minus 13. Okay, on we go to the next one. Find the gradients in x and y intercepts of the equation with this. Okay, so to start off with, that's our equation. So we'll just bring the x's and the other bits over here, and so that gives us minus 2x plus 7. Now divide through by 3, so y is going to be minus 2/3 x plus 7/3. Okay, so that therefore means the gradient, that must be equal to minus 2/3. The y-intercept, well, that's going to be equal to 7/3. Now the x-intercept, because it says x and y-intercept, so don't knock at that one. The x-intercept is going to be when y is equal to 0. It'll be probably easier to go from the original equation here. So if we put y is equal to 0, then we're going to have 2x minus 7 is equal to 0, which will easily solve to give us x, not y. X is equal to 7/2, or 3.5. Okay, on to part B. Find the equation of a line that is parallel to the line we've just been working on through the point 3, 5. So it's parallel to it, it's got the same gradient as the line we were just working on. So we can certainly say for this that y minus y1 is going to be equal to x minus x1 as before. Make sure we've got that formula buried in our brains. So we've got the point that we're going through. So that's going to be that. And our gradient is the same as what we had in the first page, which was minus 2/3. Okay, so if we just expand that bracket, that will give us minus 2/3 x plus 2. And then if we just add the 5, so y is equal to minus 2/3 x plus 7. Okay, I mean, it just says the equation of a line, so we probably should get it into y equals mx plus c. But I think you could probably still get the marks at this point. Okay, on we go to part C. Where does this line intersect this line? So two lines will be equal to each other. As we can see, this is y equals 2x plus 1, and that's got to be equal to the y form of this one, which as we had earlier was minus 2/3 x plus 7/3. So to make life easy, I'm just going to multiply through by 3 now. So 6x plus 3 is equal to minus 2x plus 7. And then that's going to be quite simply 8x is going to be equal to 4. So x will be equal to 1/2. If we pop that back into, well, we can go into either of these. Probably a hell of a lot easier to go into this one. And so y is equal to 2 lots of 1/2 plus 1. And so y is equal to 2. So that means we've got the coordinate 1/2, 2. Alright, don't just leave the x and y hanging, stick them into a coordinate. This actually means something. Right, okay, for this one, so p is minus 2, 2, q is 1, 6, r is 5, 3, and we need to show they're perpendicular. So lines are perpendicular. Write down a statement first. If gradients multiply to give minus 1. Alright, get that in first. That's your exclamation mark. Alright, don't mess around to trying to do some maths and then forgetting to write the explanation at the end. Get it in at the start. Okay, so our gradient of PQ, that's going to be 6 minus 2 over 1 minus minus 2, which is 4 over 3. And our gradient of QR, that's a ditto mark, 3 minus 6 over 5 minus 1, which is equal to minus 3 over 4. And obviously 4 over 3 times by minus 3 over 4 is equal to minus 12 over 12, which is equal to minus 1, and therefore they are perpendicular. Okay, doctor writing, but you know what it says because I said it. Okay, find the distance of RQ. So this would be these little modular symbols. That would just give the magnitude of it, and the magnitude of the segment RQ would be the distance. So this is using Pythagoras, or as our friends across the pond call it, the distance formula. 5 minus 1 squared plus 3 minus 6 all squared. You should obviously notice that that's going to be 4 squared and that's going to be 3 squared, and so it's 5, but you could ping it in your calculator if you didn't see it before. Again, no judgments here. Question 4. Find the equation of a circle with centre 2 minus 5 and diameter 16. Okay, so if your diameter is 16, that means your radius must be 4. And so, no, the radius is not 4, the radius is 8. Okay, what do I say? No judgments, just take it easy, we all mess up sometimes. Okay, x minus 2, because that's from there, all squared, plus y minus minus 5 all squared is equal to 8 squared. We'll just tidy it up. X minus 2 all squared plus y plus 5 all squared is equal to 64. Alright, cool. Okay, moving on, we're going through quite well here. Question 5. So if I center and radius this, let's just rearrange it slightly to have the x parts together. So x squared plus 4x plus y squared minus 6y minus 8 is equal to 0. Now you want to complete the square on both the x and the y parts, because that will get it back looking more like our equation of a circle. So that gives us x plus 2 all squared minus 4 plus y minus 3 all squared minus 9. We've still got that minus 8 hanging around there. That's equal to 0. And so if we just tidy up now, we've got x plus 2 all squared plus y minus 3 all squared is equal to 21. So that means our centre must be at minus 2, 3, and our radius must be equal to our square root of 21. I think we should have time to fit question 6 in. A bit more thinking. For this one, there's several ways to do this, but I am going to say that by the angle in a semicircle is 90 degrees. I just need to show the angle ABC is 90, so therefore AB is perpendicular to BC. That should say BC. I don't want to my tablet is playing it. So get your explanation in at the start. So that means that now we can find our gradient of AB. That must be equal to 6 minus 4 all over 10 minus 7, which is equal to 2/3. And our gradient of BC, that's equal to 3 minus 6 over 12 minus 10, that is minus 3 over 2. And then if I multiply them together, 2 over 3 multiplied by minus 3 over 2 is equal to minus 1. So therefore AB is perpendicular to BC, which means the right angle at B is 90, and therefore AC must be the diameter. Alright, okay, on we go now with question 7. So again, this is another circle theorem. The line segment is a chord, so we've got a circle theorem. So by circle theorem, the diameter is the perpendicular bisector of the chord. I'm just going to be bi, it might sound a bit controversial, but it's a lot shorter than perpendicular bisector of the chord. Okay, so in order to find the perpendicular bisector, we need to first of all find the midpoint of AB. And that's going to be, well, halfway between these, and so 1 plus 5 over 2 and 4 plus 1 over 2. So that is going to be at the point 3. I think we're going to use 5 over 2 because it'll just make matters easier later. And then we've got to find the gradient of AB. And so that's going to be 1 minus 4 all over 5 minus 1, which is minus 3 over 4. And therefore the gradient of our perpendicular bisector, I don't recommend writing perp bi in an exam, it might upset someone, and probably justifiably so. So write it out in full then. So you go y minus y1 is mx minus x1, and so y minus 5 over 2, I feel the need to extend the page here, is equal to 4 over 3 x minus 3. And if you wanted to tidy all that up, you could, I mean that's fine as the answer, but just to get in the super nice form of y equals mx plus c, 4 over 3x minus 3 over 2, and that's all done. That's 3. Okay, moving on to our last question. This is question 8. Now there's two ways to do this, but this this would appear to be by far the easier. So y equals k is horizontal, so we need to find the top and the bottom of the circle. Points on the circle. Okay, alright, so we've got our circle equation here, and it's nicely already in the form ready to complete the square, thanks for that AQA, and so that gives us x plus, so we're going to halve the 3, so 3 over 2, it's easier to do with the fractions, squared minus 9 over 4. And for the y ones, y plus 1 all squared minus 1, there's a 1 there, and we still got the minus 3/4 here, and look, 9/4 and 3/4, so that's 12/4, which is 3, and so x plus 3 over 2 all squared plus y plus 1 all squared is equal to 4. So that means we've got a circle now with centre minus 3 over 2. That doesn't matter so much. What matters is the y coordinate being minus 1, and the radius is going to be the square root of 4, which is of course 2. That's a 4. Okay, so that's quite good. So that means that the top of our circle must be at minus 1 plus 2, which is 1, and the bottom must be at minus 1 minus 2, which is at minus 3. So therefore k does not intersect where k is greater than 1 or k is less than minus 3. So there's our answers here. You could possibly do it a different way, but this way is far superior. There we go, that is that all done.